All right, this last example of this section, example 512, is a little bit tricky because it requires us to do a little bit of algebra before we can actually take that integral. And so let me write this down again. We have the integral of x squared plus x plus 1 all over 3x squared. And now, since this is all over 3x squared, we could look at this as x squared divided by 3x squared plus x divided by 3x squared plus 1 divided by x squared, 3x squared. And the reason we want to do that is that it will actually simplify the problem quite a bit. So since these things all have the same common denominator, we could break this up into a sum of rational expressions. So the first expression is x squared plus, or x squared over 3x squared plus x over 3x squared plus 1 over 3x squared dx. And the point here is that the stuff inside the blue parentheses is equal to each other, right? X squared plus x plus 1 over 3x squared is equal to that second expression. And that's nice because then we can simplify the ratios in that second expression. We can write this as actually a sum of integrals. So this is going to be x squared over 3x squared is just 1/3. So this is 1/3 dx plus the integral of 1 over 3x dx plus the integral of 1 over 3x squared dx. And 3x squared, I'm going to write that as 1/3 x to the minus 2 because then it makes the power rule of integration much simpler to do. And notice that you can break a integral of sums into a sum of integrals. And so now I have three simpler integrals to look at. The integral of 1/3 is just going to be 1/3 x. The integral of 1 over 3x, that's like the integral of 1/3, or it's 1/3 the integral of 1 over x. So this is equal to the integral of 1 over x dx, and you should recognize that that's the natural log of x. So this is equal to 1/3 the natural log of x. And then finally this last integral is 1/3 x to the, you're going to add 1 to the exponent, so that's -1, and then you're going to divide by that negative exponent, so that's -1 on the bottom. So this will be -1/3 x to the minus 1. So now that I've done that scratch work, let me write that down. This is equal to 1/3 times x plus 1/3 times the natural log of the absolute value of x plus 1/3 x to the minus 1 times -1, so I should make that a minus 1/3 x to the minus 1, or 1 over 3x. And then finally I need to add the constant of integration. Okay, and that is my final answer, and now I just want to check that I did everything correctly. So if I take the derivative of that expression, 1/3 x plus 1/3 ln of x minus 1 over 3, let me write that x to the minus 1 again, plus c. If I take that derivative, I will get 1/3 plus 1/3 times 1 over x minus -1 times 1/3 x to the minus 2. And that is 1/3 plus 1 over 3x plus 1 over 3x squared, which is precisely what I had, not in the very first step, but in the second step here. So these things are equal, and so I know that I took the integral correctly, and that's all there is to it.